In this video, I will cover tutorial questions 1.2 mole concept part 2 from question number 14 until question number 17. Question number 14. Step number 1 to solve this question is to list out what is being given to us. We are being given 98 grams of water, so this is mass of solvent. And we are being given the volume of NaOH solution, so this is volume of solution. And we are being given the density of solution, which is 1.33 gram per ml. And we know that density of solution is equal to mass of solution divided by volume of solution. And density of solution is 1.33 gram per ml. Mass of solution, we do not know. Volume of solution is 100 ml. Therefore, the mass of solution is equal to 1.33 gram per ml multiplied by 100 ml to give us the mass of solution as 133 gram. So that is step number 1. Step number 2, look at what we want to calculate. We want to calculate moles of solute because NaOH is the solute. So to find moles of solute, we know that the formula is mass of solute divided by the molar mass of solute. Step number 3, we do the conversions to get what we want based on the formula. So based on the formula, we want mass of solute. So how do we find the mass of solute? To find mass of solute, we can use the mass of solution minus the mass of solvent. So that is 133 gram minus 98 gram to give us 35 gram as the mass of solute. And for the molar mass of solute, we can look at the relative atomic mass for sodium, oxygen, and hydrogen. And that is 23 plus 16 plus 1 gram per mole. So that should give us 40 gram per mole. With that, then, step number 4, we can substitute what we have. Mass of solute, 35 gram, divided by molar mass of solute, 40 gram per mole, to give us the moles of solute as 0.875 mole. For question number 15, require 6 steps to follow through to solve the question because it is different from questions number 14 where we are being given specific information such as mass of solute, mass of solvent, volume of solutions, and so on. In question number 15, we are only being given density of solution and molality, one of the concentration measurement term. Therefore, to find mole fraction 15a, step number 1, we need to construct a table of solute, solvent, solution, volume, mass, and number of moles. And we can see that since we are not being given specific information, we can't put anything into the table. Therefore, in step number 2, we need to do assumptions in order for us to solve the question. So usually, I will suggest students to use the concentration measurement term to do the assumption. So since we are being given molality, which is equals to moles of solute divided by the mass of solvent in kg. Therefore, the easiest assumptions to make is we can assume that the mass of solvent is equal to 1 kg. So mass of solvent equal to 1 kg. And by assuming the mass of solvent is equal to 1 kg and the molality is 10.5 molar, we can easily find the moles of solute, which is equal to 10.5 molar multiplied by 1 kg to give us 10.5 moles of solute. So that is step number 3. We use all the assumptions information and the formula to fill into the table. And step number 4, we are calculating mole fraction. Therefore, we can write the formula for mole fraction. So we are calculating mole fractions of NaOH, the solute. So we write it as mole fractions of solute. So the formula therefore will be moles of solute divided by moles of solute plus moles of solvent. And step number 5, we do some conversion. So moles of solute we already have, but we do not have the moles of solvent. So how to find moles of solvent? We can use the formula mass divided by molar mass. So the mass here, because we are using the formula mass of solvent divided by molar mass of solvent, therefore the unit for mass of solvent must be in gram. So again, 1 kg is equal to 1000 gram. So therefore it is 1000 gram divided by the solvent here is water. So the molar mass of water is 18 gram per mole to give us moles of solvent as 55.56 mole. And in step number 6, we just need to substitute what we have in step number 5 into the mole fractions formula. So moles of solute is 10.5 mole divided by moles of solute 10.5 mole plus moles of solvent 55.56 mole to give us the mole fraction as 0.1589. Question number 15b also requires 6 steps to solve this question. So step number 1, we construct the table with solute, solvent, solution, volume, mass, and number of moles. And we can see that we can't fill anything into the table since we are not being given specific information. So in step number 2, we can do assumption. So since we are being given molality as the concentration measurement expression, so we can use molality to look for what assumptions we can make. So molality is equal to moles of solute divided by mass of solvent in kg. And based on the formula of molality, we can see that the easiest for us to do calculation is by assuming that the mass of solvent is equal to 1 kg. Then, by using our assumption and molality information, we can find that the moles of solute is equal to molality multiplied by the mass of solvent 1 kg to give us the moles of solute as 10.5 mole. Then in step number 3, we can fill in the table using the information that we get. So 1 kg mass of solvent and 10.5 mole as the moles of solute. Then in step number 4, we write out the formula for what we want to find. So we want to find percentage by mass. So the formula of percentage by mass is equal to mass of solute divided by the mass of solution multiplied by 100. Step number 5, we need to do some conversion to get what we want so that we can substitute into the formula to find the final answer. So we want mass of solute, we have moles of solute. So to find mass of solute, we know that we just need to use the number of mole multiplied by the molar mass of solute. So solute is NaOH, so the molar mass is 40 gram per mole to give us the mass of solute as 420 gram. And then we also need to find the mass of solution. So mass of solution, how to make the solution? By combining the solute with the solvent. Therefore, to find the mass of solution, we just need to sum the mass of solute with the mass of solvent. Mass of solute is 420 gram and the mass of solvent is 1 kg. In order to do the summation, their unit must be consistent. Therefore, convert to gram, that is equal to 1000 gram to give us the mass of solution as 1420 gram. Then in step number 6, we can substitute what we calculated in step number 5 into the formula. So the mass of solute is 420 gram, mass of solutions 1420 gram, multiplied by 100 to give us the percentage by mass equal to 29.58%. Question number 15C also need to go through 6 steps to solve the question. Again, step number 1, we construct the table. for solute, solvent, solution, volume, mass, and number of moles. And again, we can see that we can't fill in anything because we are not being given specific information like in question number 14. And since we can't fill in anything, so we need to move on to step number 2, make the assumption. We always make the assumptions based on what is the concentration measurement term that is being given to us. We are being given molality, so we need to do assumption based on molality. Molality formula is moles of solute divided by mass of solvent in kg. And from the formula of molality, we can see that the easiest is for us to assume that the mass of solvent is equal to 1 kg. And from that assumption and the molality that is being given, 10.5 molar, we can easily find what is our moles of solute, which is equal to molality 10.5 molar, multiplied by 1 kg to give us the moles of solute as 10.5 mole. And step number 3, we fill in the table in step number 1 with what we have found. So the moles of solute is 10.5 mole and the mass of solvent is 1 kg. Then in step number 4, we write out the formula of what we want to find. We want to find molality. So the formula for molality is equal to moles of solute divided by volume of solution in liter. Step number 5, we need to do some conversion. So moles of solute we have already, but we do not have the volume of solution. So how can we get the volume of solution? From density of solution. So density of solution is equal to mass of solution divided by volume of solutions. So density of solutions given is 1.33 gram per ml. And the mass of solution is equal to 1420 gram. So we have calculated the mass of solutions in question number 15b. So we can use it here, 1420 gram. So to find the volume of solution, we need to use the mass of solution divide with the density of solution to give us the volume of solution as 1067 ml. But in the molarity, we want it to be in liter. So to convert the volume of solutions to liter, we just need to divide by 1000 to give us 1.067 liter as the volume of solution. Then in step number 6, we just substitute into the formula moles of solute 10.5 mole and the volume of solution is 1.067 liter to give us the molarity of the solution as 9.835 mole per liter. Question number 6a also requires 6 steps to follow through to solve this question because we are not being given specific information like in question number 14. So step number 1, we construct a table with solute, solvent, solution, volume, mass, and number of mole. And step number 2, we do some assumption. So I will suggest students to do assumption based on the concentration measurement term that is being given. So in this question, we are being given percentage by mass. So the formula is mass of solute divided by mass of solution multiplied by 100. From the percentage by mass formula, we can see that it is easiest for us to assume that the mass of solution is equal to 100 gram. Because 100 gram, we can easily cancel out with the 100. So therefore, we assume the mass of solution is equal to 100 gram. And then with the percentage by mass 95% and the mass of solutions 100 gram, we can easily find our mass of solute as 95 gram. Then in step number 3, we just fill in those informations that we have. So mass of solute 95 gram and the mass of solutions 100 gram. Then in step number 4, we write out the formula of what we want to find. We want to find molarity. The formula is moles of solute divided by volume of solution in liter. Step number 5, we do some conversion to find moles of solute. So to find moles of solute, we use mass of solute, 95 gram, divided by the molar mass of solute, sulfuric acid. So that is 98.1 gram per mole to give us moles of solute as 0.9684 mole. And to find volume of solution in liter, we can use the density of solution term. So we know that density of solution is equal to mass of solution divided by volume of solution. And the density of solution is 1.84 gram per ml. And the mass of solution is 100 gram. And that should give us the volume of solution equal to 54.35 ml. And in the molarity formula, the volume of solutions must be in liter, so we need to divide by 1000 to convert it to liter, 0.05435 liter. In step number 6, we substitute what we have found in step number 5 into the formula, so 0.9654 mole of solute divided by volume of solutions in liter, 0.05435 liter, to give us the molarity of sulfuric acid as 17.82 mole per liter. Question number 16b basically is a process called dilution. So what is happening is, in question number 16a, we already calculated the molarity of the stock solution as 17.82 molar, and now we want to calculate what is the volume that we need to pipette out from the stock solution, the concentrated sulfuric acid stock solution, in order for us to prepare another diluted solution with molarity of 0.08 molar and the volume is 1 liter. So here, the first molarity, the molarity of the stock solutions, we can state it as M1, and the volume of the stock solutions that we take out as V1, and the molarity of the dilute solution as M2, and the volume of the dilute solutions as V2. Then for dilution, in order for us to calculate the unknown, we just need to use the formula M1 V1. So this is the molarity and the volume for the stock solution equal to M2 V2. And M2 is the molarity of the dilute solution and V2 is the volume of the dilute solution. And the M1 is 17.82 molar. V1 we want to calculate, and M2 is 0.08 molar. V2 is 1 liter. And then by doing the mathematical calculation, we can solve that as 4.49 times 10 to the power of negative 3 liter. So means that in order to prepare 0.08 molar of 1 liter dilute solution, we need to take out 4.49 times 10 to the power of negative 3 liter of stock solution. Question number 17a. Only 4 steps to follow through to solve question number 17a, because we are being given specific information such as mass of solute and also volume of solution. So step number 1, we list out all the informations that are being given to us. So I just did it. So mass of solute 0.4 gram and the volume of solutions 100 ml. So in step number 2, we write out the formula of what we want to find. So we want to find molarity. So the formula is moles of solute divided by volume of solution in liter. Step number 3, we do some conversion. So we want moles of solute. So that would be equal to mass of solute divided by molar mass of solute. Our solute is NaOH, so the molar mass is 40 gram per mole, to give us the moles of solute as 0.01 mole. And then for volume of solutions in liter, in the question given in milliliter, so to convert it to liter, we just need to divide by 1000 to give us the volume of solutions as 0.1 liter. Then in step number 4, we just substitute what we have calculated in step number 3 into the formula. Moles of solute 0.01 mole, volume of solution 0.1 liter, to give us molarity of the solutions as 0.1 molar. Question number 17b involves reaction between the NaOH with the sulfuric acid. So before we solve this question, we need to understand the question first. So first, in the first part of the question, so prepare 100 ml of 0.1 molar NaOH. But in order to react with sulfuric acid, only 25 ml of 0.1 molar NaOH is being used to react with the sulfuric acid. And now the question asks us to calculate the number of mole of sulfuric acid that is required to react with 25 ml 0.1 molar NaOH. So to do this question, since it involves reaction neutralization, we are being given A, NaOH, and asked for B, sulfuric acid. So usually we need 3 steps to solve it, but since the question only wants number of moles of sulfuric acid, we can just stop at step number 2. So step number 1, remember, we need to find the number of moles of A first. And here we need to find the number of moles of NaOH, since we have the molarity and the volume of solutions of NaOH. And the formula that we need to use, because this is solution, is molarity multiplied by volume of solutions in liter. And the molarity is 0.1 molar multiplied by 25 ml. We need to convert it to liter. So that would be 0.025 liter to give us 2.5 times 10 to the power of -3 mole of NaOH. Step number 2, we need to find what is the stoichiometric relationship between NaOH and sulfuric acid. For that, we need to have a balanced chemical equation because this involves reaction. So NaOH react with sulfuric acid. So that is alkali react with acid. Alkali react with acid, that will give us salt and water. And to balance the equation, we need 2 moles of NaOH react with 1 mole of sulfuric acid to give us 1 mole of sodium sulfate salt and 2 moles of water. From the balanced chemical equation, we can see that 2 moles of NaOH will react with 1 mole of sulfuric acid. So therefore, their stoichiometric relationship is 2 moles of NaOH equivalent to 1 moles of sulfuric acid. Now we have 2.5 times 10 to the power of -3 moles of NaOH. That will require X moles of sulfuric acid. And how do we find X? So mathematically, we can do cross multiplying. 2.5 times 10 to the power of -3 mole of NaOH multiplied by 1 mole of sulfuric acid divide by 2 moles of NaOH. So mole of NaOH can cancel out to give us the moles of sulfuric acid as 1.25 times 10 to the power of -3 moles of sulfuric acid.